So we need to review rational functions a little bit. And the compelling part of a rational function is that you're going to have an asymptote, right? They're all about asymptotes. And an asymptote is always about infinity. An asymptote always involves infinity in some way, shape, or form. So first let's talk about a vertical asymptote. For a vertical asymptote, the graph is always going to infinity, right? Up along it, down alongside the other side. So right over here, I can see that I have a vertical asymptote, and the equation for this vertical asymptote, right? The equation for this red line that kind of serves as a guide for my black graph is it's always x equals something, right? And vertical line always has equation x equals, and x equals at any point on here, when x is 4. So here the equation for the vertical asymptote is x is equal to 4. And here's what that means. What it means is that the graph, I can see it going up to infinity. I can see the fact that the y values, if I went in this direction, get higher and higher and higher. And over here, they get lower and lower and lower, right? So, and that's the nature of infinity. As x gets close to 4, right, from one direction, y gets closer to infinity. And as x gets close to 4 from, in fact, this is from the right and from the left, y gets close to negative infinity. But that's what we're looking for. For this next one, what I can see is that we're going to have an asymptote, this red line, this behavior right over here at x is equal to -2. And over here, right, you can't tell. You can't tell where the asymptote is. I did not draw a vertical red line. Nevertheless, look for where the graph is going up and up and up and up and up, right over here, right? So the y is getting really, really big the closer we get to this line. And the equation for this vertical line, well, x is 0 there. So that's where x is equal to 0. Now, let's talk about what the equation would look like. For the equation for a vertical asymptote, we always look for where the bottom is equal to 0. So over here, what would x have to be for this bottom to be equal to 0? Well, for this to be 0, if I have plus 2, x would have to be -2. So that's where I would have a vertical asymptote. Over here, I don't care about the fact that I have subtracting 3. I'm still going to look at the bottom of the fraction. So my vertical asymptote is still at x is equal to -2. And even over here, right, I have a 5 in the top. I don't care about what's going on. I just care about the bottom. X cannot equal to 6, or the bottom would be 0. So that's the equation for my vertical asymptote, wherever the bottom of the fraction would be 0, as long as it doesn't cancel, and that's another story. Over here, right, a little more complicated, but still, I'm just looking for where the bottom would be 0, so x can't be 6. So this is the equation of the vertical asymptote. So to find the vertical asymptote in an equation, you always look to the bottom of the fraction. Now, let's talk a little bit more about that to make it agree with what we just set up here. Okay, so you're saying x can't be equal to -2, and here's what I want to do. I want to test this, and I'm going to take this function that we have. I'm going to take this function that we have, and I'm going to plug in something very close to -2. I'm going to plug in x is -1.9 and just see what happens. So this is, I hope you can see this, 1 divided by parentheses -1.9 plus 2, and that's going to give me 10. I'm going to get a little bit closer now and see what happens. -1.99. So I'm looking for the trend. As x gets closer to -2, what happens to the output? Last time it was 10, now it's 100, right? That's getting big. That's getting big. So as I control how close x gets to -2, what I can see from my calculator is that the y value is going to infinity. So that's the real reason that we have a vertical asymptote at x is equal to 2.